12th chapter in your textbook, equation of a straight line. In this chapter, we shall find the equation of straight lines in different forms. So before learning the different forms of equation of straight line, we have to understand certain terms and definitions. First of all, let us see what is meant by inclination. Inclination of a straight line. Consider a straight line in the coordinate plane. This line meets x-axis with an angle theta to the positive direction of the x-axis. So, inclination is the angle made by the line and the x-axis, or the term inclination means the angle that the line makes with the positive direction of the x-axis and measured in the anti-clockwise direction. So theta, here theta is the inclination of the given straight line. If theta is 30 degree, then the inclination of the straight line is 30 degree. If theta is 45 degree, then the inclination is 45 degree, or if theta is 50 degree, then the inclination is 50 degree, and so on. Now let us see what is the slope of a line. Slope. Slope is also known as gradient. If theta is the inclination of a line, the trigonometric ratio tan theta. Tan theta is known as the slope of a line. The value of tan theta is the slope of the given line, and the slope is usually denoted by the letter m. So slope of a line is equal to tan theta, where theta is the inclination of the line. So for example, if theta is 30 degree, then slope m is equal to tan 30 degree. Tan 30 degree, that is equal to 1 by root 3. So if theta is 30 degree, the slope of that line will be 1 by root 3. Suppose theta is 45 degree, if theta is 45 degree, or the inclination of the line is 45 degree, then m is equal to tan 45, that is equal to 1. So this way we can find out the slope of a line. Now let us see what are intersects. If a straight line meets x-axis at A and y-axis at B, the origin is represented by O. The distance OA is known as the x-intercept. OA is the x-intercept, and the distance OB is known as the y-intercept. The straight line meets x-axis at A and y-axis at B. The distance OA is the x-intercept and OB is the y-intercept. Here OA is measured at the right of the origin, that is why x-intercept is positive. If OA is measured at the left of the origin, then the x-intercept will be negative. Similarly, here OB is measured above the origin, therefore y-intercept is positive. If it is measured below the origin, the y-intercept will be negative. The y-intercept is usually denoted by the letter C. Now let us understand the equation of a straight line in different forms. First of all, equation of straight lines parallel to x-axis and equation of straight lines parallel to y-axis. So let us consider a straight line parallel to x-axis at a distance A from the x-axis. This distance is A. We consider it as A. Now, everywhere on this line, the value of y remains same. This is the value of y. This line is parallel to x-axis. That means everywhere the distance between this line and the x-axis remains same, and that distance is A. Now, this value of y So the equation of a line parallel to x-axis is y is equal to a. So from this we can also obtain the equation of x-axis. X-axis is parallel to itself at a distance 0 units. That means x-axis is formed as y is equal to 0. The equation of x-axis is y is equal to 0. Similarly, consider a line parallel to y-axis at a distance b from the y-axis. At a distance b unit from the y-axis. This line is parallel to y-axis. That means everywhere the distance between the y-axis and the line is same. Now, this is b units. The distance between the y-axis and the line and the considered line is b units. That means the value of x here is b. Therefore, that means everywhere on this line the value of x will be same. That is b. Therefore, this line can be formed as x is equal to b. So from this we can also obtain that the equation of y-axis, that is x is equal to 0. So these are the equations that are parallel to x-axis and parallel to y-axis. Equation of a line parallel to x-axis is y is equal to a, where a is the distance between the line and the x-axis, and equation of a line parallel to y-axis is x is equal to b, where b is the distance between y-axis and the considered line. Now let us learn the slope intercept form of an equation. Consider an equation with an inclination of theta and a slope m. The slope of this line is taken as m, and it meets y-axis at the point 0, c, where c is the y-intercept, the distance between origin and this point, the point at which the line meets the y-axis. That is the value of y-intercept, or that is the distance c. So this equation can be written as the equation of this line can be written in the slope intercept form as y is equal to mx plus c. So for a straight line, if the slope and the y-intercept are given, we can form the equation as y is equal to mx plus c, where x and y are variables and m and c are constants. That means m is the slope and c is the y-intercept. So this is the slope intercept form of the equation. Now let us learn the Poinsberg form of an equation. Consider an equation with a slope m. Here this point slope form, so we are given with the slope. Slope of this line is m, and it passes through a point x1, y1. It can be any point in the coordinate plane. It is given that the straight line has a slope m, the value of the slope will be given, and a point through which the line passes also will be given. Now the equation of this line can be written as y minus y1 is equal to m into x minus x1. Here y and x will be variables and x1, y1 will be given. They are given points and m is the slope. So that is a Poinsberg form of an equation. Y minus y1 is equal to m into x minus x1. In this, the slope will be given and also a point through which the line passes will be also given. Now let us see the two-point form of an equation. In this, a straight line is given and it is also given that it passes through 2 points. 2 points are given through which the given straight line passes. We have to find out the equation of that straight line. That equation can be formed like this: y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. This is the 2-point format of an equation. In this, only 2 points will be given through which the line passes. So the equation can be formed like this: y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. In this, y and x are variables and x1, y1, x2 and y2 are the values of the coordinates given. Now from this, by comparing this equation with the Points law form, we can find out the value of m as the Points law form was given y minus y1 is equal to m into x minus x1. So we can compare them and we can find out the value of slope like this. If on a straight line 2 points are given, we can find out the slope of that straight line by this formula, that is m is equal to y2 minus y1 by x2 minus x1. So this is the formula for finding out the slope of a straight line on which 2 points are given. So let us revise once again slope intercept form of an equation. Y is equal to mx plus c, where m is the slope of the line and c is the y-intercept. Now Points law form, y minus y1 is equal to m into x minus x1, where m is the slope of the line and x1 y1 is a point through which the given line passes. Now if 2 points are given, then we can find out the equation of that line like this. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Now let us solve some questions related to this topic. In exercise 12.1, question number 6, third one. It is given that find the equation of line whose gradient is equal to root 3 and y-intercept is equal to minus 4 by 3. So here it is exercise 12.1, question 6, third one. Here it is given that gradient is slope itself, and that is m equal to root 3 and y-intercept is equal to, it is denoted by c, that is equal to minus 4 by 3. Here slope and y-intercept are given. We can find out the equation with the form y is equal to mx plus c. So the required equation can be formed like this: y is equal to root 3x plus minus 4 by 3. So one thing we have in noted, whenever we write the equation of a straight line, it has to be written in its standard form, that is ax plus by plus c is equal to 0. X term plus y term plus constant term is equal to 0. This is the standard form of equation of a straight line. So every equation which we form should be finally written in that form. So we have to make it into that form, that is y is equal to, take the LCM, 3 root 3 plus 3 root 3x plus minus 4 all divided by 3, which implies 3y equal to 3 root 3x minus 4 implies 3 root 3x minus 3y minus 4 is equal to 0. This is the equation in its standard form. 3 root 3x minus 3y minus 4 is equal to 0. Now question number 7, first one, find the slope and y-intercept of the following lines. 7, first, find the slope and y-intercept. Here the equation is given as x minus 2y minus 1 is equal to 0. It is given in its standard form, but to find out the slope and y-intercept, we need to convert this into the slope intercept form, that is y is equal to mx plus c. So by keeping minus 2y at the left, we get minus 2y is equal to minus x plus 1, y is equal to minus x by minus 2 minus 1 by 2, or it can be written as y is equal to 1 by 2x minus 1 by 2, that is in the form y is equal to mx plus c. So here slope m is equal to 1 by 2 and y-intercept c is equal to minus 1 by 2. So these are the slope and y-intercept of the given equation. Now we shall solve question number 12. The graph of the equation y is equal to mx plus c passes through the points 1, 4 and minus 2, minus 5. determine the values of m and c. So here we have the equation y is equal to mx plus c, and 2 points through which this line passes through 1, 4 and minus 2, minus 5. Now the equation y is equal to mx plus c passes through 1, 4. The point 1, 4 means that we can substitute the value of x and y with the 1 and 4. That implies the value of y will be 4 equal to m into 1 plus c. Implies we can write m plus c is equal to 4. That is equation number 1. Similarly, y is equal to mx plus c passes through minus 2, minus 5, implies we can also substitute the value of x and y here. That is minus 5 is equal to m into minus 2 plus c. Simplifying, we get minus 2 m minus 2m plus c is equal to minus 5. This is question number 2. Now, this is a pair of simultaneous linear equations with the variables m and c. By solving this, we can find out the value of m and c. That is, subtracting equation number 2 from equation number 1, we get m minus minus 2m. That is 3m, and c will be cut, is equal to 4 minus minus 5. That is 4 plus 5, 9. That implies m is equal to 3. Now substituting the value of m in the first equation, we get c is equal to, here 3 plus c is equal to 4. That means c is equal to 1. So the value of m is 3 and c is equal to 1. Now moving on to question number 20. Find the value of a for which the following points a3, b21 and c5a are collinear. Hence find the equation of the line. So here it is given that these 3 points are collinear. That means if we consider the slope of AB and the slope of BC, both will be equal. So we can find out the slope of AB and slope of BC separately. Here we have the points A1, A3, B21 and C5A. So these are the points. This is A, this is B and this is C. If you consider AB and BC are 2 separate straight lines, since it is given that they are collinear, these 3 points are collinear, the slope of AB will be equal to slope of BC. Therefore, we can write slope of AB is equal to slope of BC. Now, slope of AB can be obtained by the formula y2 minus y1 by x2 minus x1. That is, slope of AB can be obtained as y2 minus y1, 1 minus 3 divided by x2 minus x1, 2 minus a is equal to slope of BC can be obtained as y2 minus y1, a minus 1 by x2 minus x1, 5 minus 2. Simplifying it, we get minus 2 by 2 minus a equal to a minus 1 by 3. Doing cross multiplication, minus 6 is equal to a minus 1 into 2 minus a. Simplifying, minus 6 is equal to 2a minus a square plus minus 2 plus a. Further simplification, we get a square minus 3a minus 4 is equal to 0. So this is a quadratic equation in A. We have to solve it. By solving this quadratic equation, we can find the value of A as, here we can get factorized as A minus 4 into A plus 1 is equal to 0, implies A is equal to 4 or A is equal to minus 1. So the values of A are 4 and minus 1. Now substituting these values in the given coordinates, we get, first of all, if A is equal to 4, we have the points A, 4, 3 and we also have B, 2, 1. For finding out the equation, we need only 2 points. We can apply the 2-point form, or by finding out the slope, we can also apply the point slope form. So here we are going to apply the 2-point form. Okay. So we have A 4, 3 and B 2, 1. So the equation of the required line is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. So this is the required equation. In this we will substitute the values of x1, y1, x2 and y2. So y minus y1 3 is equal to y2 minus y1 1 minus 3 divided by x2 minus x1 2 minus 4 into x minus x1, that is x minus 4. By simplifying this, we can get the required equation. Y minus 3 is equal to minus 2 by minus 2 into x minus 4, that is minus 2 divided by minus 2 will be 1 itself. So y minus 3 is equal to x minus 4, implies, by simplifying it, we will get x minus y minus 1 is equal to 0. In the standard form of the equation, we can get it as x minus y minus 1 is equal to 0. We can also substitute the value for a as minus 1. So let us write, if a is equal to minus 1, then the coordinates of a is minus 1, 3 and given coordinates of b are 2 and 1. Any 2 points we can take to apply the 2-point form. So by applying the 2-point form, we get the equation like this: y minus y1, y minus 3 equal to y2 minus y1, that is 1 minus 3 divided by x2 minus x1, that is 2 minus minus 1 into x minus x1, that is x minus minus 1. So by simplifying this, we get y minus 3 is equal to, here we have minus 2 by 3 into x plus 1. Simplifying, we get 3 into y minus 3 equal to minus 2 into x plus 1, implies 3y minus 9 equal to minus 2x minus 2, that is we get 2x plus 3y minus 7 equal to 0. Now we will solve question number 31. Find the equations of the diagonals of a rectangle whose sides are x is equal to minus 1, x is equal to 2, y is equal to minus 2 and y is equal to 6. The rectangle is given, whose sides are given. The equation of the lines on which the sides remain are given. That is x is equal to minus 1. This is the line one that includes one side. Then x is equal to 2. Then y is equal to minus 2 and y is equal to 6. So these are the given sides. Now from these sides we can find out the coordinates of the vertices of this rectangle. So this coordinate can be obtained as we know that this value is, the value of x here is 2 and the value of y here is 6. So this can be taken as A 2, 6. Similarly here this vertex can be taken as B minus 1, 6 and this vertex can be taken as C. The value of x here is minus 1 and the value of y here is minus 2. So C minus 1 minus 2 and the last vertex D can be taken as D 2 minus 2. So these are the vertices of the given rectangle, that is A 2, 6, B minus 1, 6, C minus 1 minus 2 and D 2 minus 2. Now from these vertices we can find out the equation of the diagonals, that means diagonal AC and diagonal BD. So AC can be obtained from these two points and BD also can be obtained by these 2 points. 2, 6, B minus 1, 6, C minus 1 minus 2 and B 2 minus 2. These are the coordinates of the vertices. Now we can find out the equation of diagonal. So here we can apply the point slope form. For that we have to find out the slope of each diagonal. First of all, slope of diagonal AC. Slope of AC is equal to, this is the point A, 2, 6 and point C, minus 1 minus 2. Slope of AC is 5 2 minus 5 1 minus 2 minus 6 divided by x2 minus x1 minus 1 minus 2 is equal to minus 8 by minus 3, or it is 8 by 3. So slope of AC is 8 by 3. Now we can apply the point slope form. Any one of the points we can use, that is we use the point A. So y, equation of AC is y minus y1, y minus y1, that is 6 is equal to m into 8 by 3 into x minus x1, x minus 2 implies 3 into y minus 6 is equal to 8 into x minus 2, simplifying 3y minus 18 is equal to 8x minus 16 implies 8x minus 3y plus 2 is equal to 0. This is the equation of diagonal AC. Similarly, we can find out the equation of diagonal BD. Here we write slope of BD. Slope of BD is equal to, here these are the 2 points we consider. In that we apply the formula y2 minus y1 divided by x2 minus x1. So y2 minus y1 is minus 2 minus 6 divided by x2 minus x1. 2 minus minus 1, that is equal to minus 8 by 3. Now equation of BD implies, it's also in the point slope form, y minus y1. We have to take any of the points. Here we take the point B, y minus 6 y minus 6 is equal to minus 8 into x plus 1. That is 3y minus 18 is equal to minus 8x minus 8. Further simplification, we get 8x plus 3y minus 10 is equal to 0. So this is the equation of the diagonal BD.